for checking into What the Blog, an Essentials mini-series discussing the most shocking, insightful, and just plain fascinating articles and industry experts we've discovered through the last week. In each episode, we bring you snippets of trending news directly from the experts that curate our newsletters across the 32 topics we cover. I'm one of the Essential editors, Isabella, and while you mostly see me with Martin, today I have the great opportunity to speak with Dillon Laird, who's currently engineering manager at Landing AI, which was actually founded by Dr. Andrew Ng, who is a globally recognized leader in artificial intelligence. So welcome, Dillon. How are you?
Good. Thanks for having me.
Perfect. So I just wanted to kick things off by discussing how much AI has been in the news lately, from startups to integration in all kinds of products and services. And despite so much progress, especially in relation to consumer internet businesses like web search and e-commerce, it's still struggling to gain traction in other industries. So what do you think is wrong and how can we overcome it?
Yeah, so kind of, I can't speak to all the industries, but the one I work in, vision, there's still some big kind of problems remaining that make it difficult for us to kind of, fully do all the things we want to do. One of those problems is, when you look at a lot of these machine learning data sets, about 80% of the data is easy. You've got lots of data for it, well-defined classes. And then there's kind of a tail end 20% that's a lot harder to correctly identify. And oftentimes it's very critical to be able to build a model to identify that tail end of the problem. So, like in manufacturing, this is defects, right? So we have tons of okay data, but obviously the manufacturer is not trying to, manufacture defects. And therefore we have very few data for those types of classes. Yet they're incredibly critical for deploying a model and having it be successful. And then, if you look at like Tesla, for example, you have got the whole, assortment of edge cases that are super critical for them to get right, like stop signs or detecting school buses, that they may or may not have a lot of data on all the different side cases for those. So being able to kind of handle these tail end problems is super critical for deploying successful machine learning models.
Okay, yeah. So on June 17th, Deep Learning AI and Landing AI teamed up to launch the contest to improve AI systems by, I guess, refining the data that it depends on. And from what I understand, this is a move within a campaign to supercharge the way AI is built and what it can do. So maybe you can tell me more about the contest and how you're going to try and get experts and AI engineers to move into a more data-centric approach.
Yeah, so this was kind of our first attempt at this. So hopefully, there'll probably be many iterations and a lot of learnings from this, but it is kind of make like a mini sort of in this like competition. So we picked hand-drawn Roman numerals, and then we tried to, make it a lot like a real world problem. So there's lots of ambiguities in the data, right? Is, you could draw like a V, or if they're slightly crossed, is that an X? There's like little things like that. And so we built this data set, we put in these different ambiguities, and what we do is we fix the model so the user can't modify the model or change the architecture or anything like that. And obviously we fix the test set, but we give the user full access to modify the train and validation set. So they can use whatever techniques they want to pick the right validation set, find issues with the training data, modify the training data, add new training data, or validation data, and use only the data to improve the performance of the model, which is a lot like what we end up doing in our problems. We usually don't, the models have, for the most part, been commoditized, are pretty good. So we don't spend a lot of time, playing around with new state-of-the-art models. We mostly spend our time fixing our data, redefining our labeling books, and doing things like that.
And do you think then that the real way to get these AI engineers to embrace this approach is just to spread knowledge that this is actually the most important? Is it just on that level, or what is your rationale?
Yeah, I think that's a big thing. I mean, when I came out of school, after taking a lot of AI classes, um, I don't think any one class ever mentioned anything about data-centric approaches. And that's what we're seeing with a lot of these companies we work with. They hire a lot of really good AI talent, but they're coming from this very model-centric approach. Their whole idea is, oh, I want to build the best state-of-the-art model, and it's going to solve my problem, and I don't want to spend time labeling and fixing the data. When in fact, that usually does not end up helping, and actually typically a much better approach is to just pick a basic, I don't know, like ResNet model, and then really make sure that your data is clean and you're looking at all your side cases, and your labeling book is very precise. So I think if we were able to kind of introduce this earlier on, so um, have more papers discussing this issue, B, teach more classes, to teach how to solve this very real world problem. People would be a lot better prepared for solving real world AI problems.
Okay, and why do you think that schools or like traditional teaching methods have focused on more of like a model approach rather than, putting more emphasis on the data, picking a simpler model to start with? Is there a reason? Is it just that we've learned more as time goes on about what's really more important, or is this just how things have been and they continued?
Yeah, that's a good question. I don't know if I could say too much about what it was like in the 80s or 90s or earlier.
Mhm.
But I mean, at least with the deep learning boom, kind of maybe from like 2010, you needed to have a lot of like research on the models. I mean, there was a lot, if I were to look at like the performance gain between iterating on the model and the data, well, if you didn't have those like ResNets and stuff, you could make a lot of progress just focusing on the model because there was a lot of progress to be made. But at this point in time, with the current deep learning models, I think they're good enough. And the new architectures, at least the way we test them out, they're honestly we're not getting huge gains on these real world data sets that we see. We have to move to this other approach and focus more on the data.
Okay, well, I think you provided some great insight, and I think that our readers and watchers now will find it really helpful. So thank you again, Dylan, for your time. And to our watchers, we'll see you next week. Thank you.
Awesome. Thank you.